Exadata key features are Smart Scan or cell offloading, storage indexes, hybrid columnar compression, I/O resource manager, smart flash cache, flash logging, smart scan or cell offloading. Smart Scan is one of the great feature in Oracle Exadata. With this technology, storage send only required byte to database node from storage instead of entire Oracle block. Multiple rows are stored in one Oracle block, but non-Exadata system return entire block even only one rows is required. On the other hand, Exadata storage returns only interested bytes, not entire block. Storage indexes. A storage index is a memory-based structure that reduces the amount of physical I/O performed in an Exadata cell. The storage index keeps track of minimum and maximum column values, and this information is used to avoid useless I/OS. Exadata hybrid columnar compression. Oracle introduced basic compress feature from Oracle 9i version. Exadata hybrid columnar compression can be specified at table or table partition and table space level. Not suitable for data which is frequently changing. Locking at CU level instead of row level, so potentially many rows could be locked instead of single row. Data needs to be loaded using direct path loads like parallel DML, insert / plus append */ direct path SQL loader. Smart flash cache. Oracle Exadata Smart Flash Cache stores frequently access data in flash storage which is very fast than other storage. This happens automatically and user don't need to take any action to use this feature. Flash cache is smart, it avoids caching data which will not be reused or which is too big to fit in cache. The Exadata storage server software also provides the Exadata Smart Flash logging feature to speed database log I/O. Here are more details about these features. What is Smart Scan? Smart Scan is one of the great feature in Oracle Exadata. With this technology, storage send only required rows to database node from storage instead of entire Oracle block. Multiple rows are stored in one Oracle block, but non-Exadata system return entire block even only one rows is required. On the other hand, Exadata storage returns only interested rows but not entire block. How does Smart Scan work? With Smart Scan technology, the database servers or compute nodes send additional query details to the storage cells via a protocol known as IDB, Intelligent Database Protocol. Armed with this information, the storage cells can take over a large portion of the data-intensive query processing. Exadata storage cells can search the storage layer with this added intelligence about the query and send only the relevant bytes, not all the database blocks, to the database compute nodes. The SmartScan sends a more concentrated set of rows and columns directly to the Program Global Area, PGA, of the requesting process instead of the data buffers in the SGA. SmartScan includes full table and fast full index scans. Scans are performed inside Exadata storage server, rather than transporting all the data to the database server. Predicate filtering, only the requested rows are returned to the database server, rather than all the rows in a table. Column filtering, only the requested columns are returned to the database server, rather than all the table columns. Join filtering, join processing using Bloom filters are offloaded to Exadata storage server. How classic or non-Exadata database processes I/O or SQL request. With conventional storage, all the database intelligence resides in the software on the database server. To illustrate how SQL processing is performed in this architecture, an example of a table scan is shown in the graphic on the screen. 1. The client issues a select statement with a predicate to filter a table and return only the rows of interest to the user. 2. The database kernel maps this request to the file and extents containing the table. 3. The database kernel issues the I/OS to read all the table blocks. 4. All the blocks for the table being queried are read into memory. 5. SQL processing is conducted against the data blocks searching for the rows that satisfy the predicate. 6. The required rows are returned to the client. As is often the case with large queries, the predicate filters out most of the rows in the table. Yet all the blocks from the table need to be read, transferred across the storage network, and copied into memory. Many more rows are read into memory than required to complete the requested SQL operation. This generates a large amount of unproductive I/O, which wastefully consumes resources and impacts application throughput and response time. How Exadata database processes I/O or SQL request by using SmartScan. Queries that perform table scans can be processed within Exadata cells and return only the required subset of data to the database server. Row filtering, column filtering, sum join processing, and other functions can be performed within Exadata cells. Exadata storage server uses a special direct read mechanism for SmartScan processing. 7. The client issues a select statement to return some rows of interest. 8. The database kernel determines that the data is stored on Exadata cells, so an IDB command representing the SQL command is constructed and sent to the Exadata cells. 9. The Exadata storage server software scans the data blocks to extract the relevant rows and columns that satisfy the SQL command. 10. Exadata cells return to the database instance IDB messages containing the requested rows and columns of data. These results are not block images, so they are not stored in the buffer cache. 11. The database kernel consolidates the result sets from across all the Exadata cells. This is similar to how the results from a parallel query operation are consolidated. 12. The rows are returned to the client. Moving SQL processing off the database server frees server CPU cycles and eliminates a massive amount of unproductive I/O transfers. These resources are free to better service other requests. Queries run faster, and more of them can be processed. What is storage index in Exadata system? Storage index in Exadata is another important feature which helps to reduce useless I/OS for query execution. A storage index is a memory-based structure that reduces the amount of physical I/O performed in an Exadata cell. The storage index keeps track of minimum and maximum column values of a chunk and grid disk, and this information is used to avoid useless I/OS. A few point of storage indexes. Normal index in database maps location of rows of the table. On the other hand, Exadata storage index don't locate rows of table. They identify the areas, storage regions, that definitely will not contain the values, thus eliminating them from I/O processing. They act as negative indexes, just the opposite of traditional database indexes, which are for locating, not eliminating, the database blocks that may contain the information. Storage indexes are not stored on disk, they are resident in the memory of the storage cell servers. They are created automatically after the storage cells receive repeated queries with predicates for columns. No user intervention is needed to create or maintain storage indexes because they are memory resident structures. Few limitations. Storage indexes are mostly used for full table scan. As storage indexes are created during runtime and store in memory, so it will disappear when the storage cells are rebooted or need to overwrite for memory storage or aged out. Storage indexes are not useful for encrypted table. Hybrid columnar compression. Oracle introduced basic compress feature from Oracle 9i version. Exadata hybrid columnar compression can be specified at table or table partition and table space level. Not suitable for data which is frequently changing. Locking at CU level instead of row level, so potentially many rows could be locked instead of single row. Data needs to be loaded using direct path loads like parallel DML, insert / plus append */ direct path SQL loader. Two types of compression options are available for Exadata. Warehouse compression, optimized for query performance as it's reduced the I/O and mostly for data warehouse type of applications. With this option, compression can be up to 10x. Compress for query, low, high. Archive compression, optimized for maximum compression ration for space and recommended to use this option if data changes rarely. With this option, compressed can be 10x to 50x. Compress for archive, low, high. Data organization with hybrid columnar compression. Exadata hybrid columnar compression data is organized into sets of rows called compression units, CU. Data is organized by column in CU and then compressed. Data is organized by column during loading. Each column is compressed separately. HCC is supported by SmartScan. Table is organized into compression units. Oracle Exadata Smart Flash Cache. Smart Flash Cache. Oracle Exadata Smart Flash Cache stores frequently access data in flash storage which is very fast than other storage. This happens automatically and users don't need to take any action to use this feature. Flash cache is smart, it avoids caching data which will not be reused or which is too big to fit in cache. The Exadata storage server software also provides the Exadata Smart Flash logging feature to speed database log I/O. Area of use is Smart Flash Cache. Compute nodes, database, send I/O requests to the storage cells with predictive information is embedded into these requests via IDB protocol. IDB protocol has the information about special I/O requests, like redo log write, buffer cache read, ASM cache I/O, control file write or smart scan, sending from database instance to cell. Data and index block reads and writes will benefit significantly from a caching mechanism. Control file I/O, archive log I/O, ARM and DB backups and restores have no benefit from the use of caching. How can influence to use Smart Flash Cache? During creation of objects by using cell_flash_cache parameter, we can influence to use Smart Flash Cache. Cell_flash_cache, default, keep, none. Default, uses a prioritized least recently used algorithm, the oldest data is aged out first. Keep changes the LRU algorithm by maintaining the data in the cache for as long as possible. None disables the use of the Smart Flash Cache for that object. To prevent keep data from hogging the cache, no more than 80% of the configured cache is available for data tagged as keep. Even we can enforce for a table or index to use Smart Flash Cache by using alter table or index command. Alter table table_name storage, flash_cache, none default keep. Alter index name storage, flash_cache, none default keep. Exadata Smart Flash Cache compression feature has been introduced from Exadata Storage Server Software 11.2.3.3. Dynamically increases the capacity of the flash cache by transparently compressing data as it is loaded into the flash cache. Smart Flash Cache Mode. Write-through flash cache mode. Write-through mode is excellent for absorbing repeated random reads and commonly found in OLTP applications. Write-back flash cache mode. Write-back mode is best for write-intensive applications and commonly found in OLAP applications. Write-through flash cache mode. Write-through flash cache is default mode. Write-through mode is best suited to the random repeated reads commonly found in OLTP application. The data is written directly to the disk through 512 megabytes of battery-backed cache on the Exadata Cell disk controller without the intervention of flash. Acknowledgement is sent back to the database by CellServe via IDB protocol. Write performance neither improved nor diminished by this method. If the data block qualifies the caching criteria, it is written to flash cache. Subsequent read operations of the same data will benefit as data is now cached in flash. Celladmin at Exasel01, $Clyde G cell_servers L celladmin Celcli E list cell attributes flash cache mode. Steps to enable write-through mode. Cell CLI alter flashcake all flush. Cell CLI drop flashcake. Cell CLI alter cell shutdown services CellServe. Cell CLI alter cell flash cache mode equals write-through. Cell CLI alter cell startup services CellServe. Cell CLI create flashcake all. Write-back flash cache mode. Write-back mode is best for write-intensive applications. For many applications, most I/O is serviced by flash. If any application is write-intensive and if one finds significant waits for free buffer waits or high I/O times noted in AWR reports, then write-back flash cache is the best suitable option. If problem is detected, I/O operations transparently fail over to mirrored copies of data also on flash. How write-back mode works. Suitable writes go to flash only. Data is automatically written to disk as it ages out of the cache. Active data blocks can reside in flash indefinitely. Reads are handled the same way as in write-through mode. Steps to enable write-back mode. Cell CLI drop flashcake. Cell CLI alter cell shutdown services CellServe. Cell CLI alter cell flash case mode equals write-back. Cell CLI alter cell startup services CellServe. Cell CLI create flashcake all.